Hey everyone, I wanted to try to go through as much of the pink packet that I could with you guys tonight. I know it's a little late because you already took your practice test, and I am making some copies of this, but I wanted to go over it, and I think it's a really good idea that you guys watch these videos and review them and look over your notes. Make sure you take additional notes onto these things. So for topic 3, we're talking about distribution. Now, for one of your short answer questions, you're going to have to analyze and compare distributions. So what you're going to have to do is talk about the shape, outliers, or other points of interest, center and spread. And remember, center means mean or median, and spread means standard deviation and IQR. And we always use the acronym SOX to help you. Now, as far as finding mean and median, remember that you can always do 1var stats in your calculator to help you figure that out, and enter in your values. But in order to find it, remember that it's always seen as far as mean, it's the sum of the observations divided by the number of observations that you have, and it's also known as a balancing point. That's going to come up quite a bit for you guys. And the median is known as the midpoint of the data. And if you think about how a median is calculated, that makes a lot of sense, because you put everything in order and you find the middle number, and that's exactly what the median is. Remember that the mean is not resistant to outliers, but the median is, okay? And very often when we use skewed data, we almost always look at the median and IQR. Normally though, with our distributions and our hypothesis testing, we're using mean and standard deviation. Understand what a normal, I know that doesn't look normal and I apologize, what a skewed left and skewed right, uniform and bimodal distribution look like, okay? Remember that in a skewed left distribution, the mean is less than the median, and a skewed right, the mean is greater than the median. Uniform and bimodal, the mean is usually equal to the median. You're not going to see a lot of bimodals. You might see 1 or 2 uniform. Okay, now here are the formulas for standard deviation, variance, and mean. Again, you don't necessarily need to know them because we have our handy dandy calculator and we use 1var stats for that. So as far as standard deviation is always paired with the mean, and it is not resistant to outliers. Variance is the square of the standard deviation, and it's also not resistant to outliers, and it's paired with the mean. Q1 and Q3, lower quartiles and upper quartiles. Remember, those are calculated in your calculator as well. You take the midpoint between the lowest value and the median, and that's Q1, and the midpoint between the median and the highest value, and that's Q3. Okay, those are resistant to outliers, so that makes it really nice. Okay, and then we talk about range and interquartile range. We usually use range and interquartile. We usually use interquartile range more than we use range. The reason why we use IQR is because it is more resistant. We can use range. It's not used a lot. We look, as far as other measures of spread, we look at standard deviation and variance, or IQR. Okay? Remember that you remember how to calculate the whether or not there's outliers, and that's using the 1.5 IQR rule. So what you do is you calculate the IQR, which you can do in 1var stats. You get Q3 minus Q1 and Q1, and you just subtract the two, and that's your IQR. Multiply that by 1.5, and then subtract it from Q1, and anything below that is an outlier, and then add it to Q3, and anything above that is an outlier. Okay? And we used an example where we're given this information, and we're saying, okay, is there an outlier here? Well, the minimum here is considered an outlier because it's below using our IQR rule, 1.5 times the IQR, taking it away from Q1. Okay, and then down here, I wanted to kind of point out, when you're looking at a box and whisker plot, what represents the median, what represents Q3 and Q1, your max and your min. And one of the things that we love about box and whisker plots is this right here represents your IQR, right here. It's very visual. And then also this is your range right here. Okay? Understand how to read stem and leaf plots, dot plots, and histograms. And make sure you take a look at these notes, okay? It doesn't show the shape of the distribution, a histogram doesn't, but it does show outliers, so it's kind of nice. Make sure if you're putting together a stem and leaf plot that you always show a tree, and this is what a two-sided stem and leaf plot looks like. And then a histogram, you can always use your calculator to help you with a histogram, okay? So you can always use your calculator to help you graph it, okay? And then the number of data points, you find the position of the median, and the interval containing the median is going to be 75 to 80. Okay? All right. I know I'm going through some of this kind of quickly because we did go through a lot of this already in class, but I wanted to give you guys a summary of it, and I will hopefully go through till the end as much as I can. All right. So for normal distributions and z-scores, please, please, please remember the 68, 95, and 99.7 rule. If I were you, I would take my formula sheet and draw this on my formula sheet and fill all this in. So that's going to help me significantly answer some questions. Okay? So we use a mean and standard deviation with a normal distribution. And usually the mean is right about the center. Okay? Now, understand and be able to explain what a z-score is. Okay? It's the number of standard deviations above or below the mean, and you are required to know how to calculate that. You will not be given that formula at all, and you're going to have to solve for standard deviation, possibly compare two things. So this is an excellent example when we're talking about apples and oranges, which is kind of funny because we're comparing two things that are not alike. And we also did that with the ACT and SAT examples. So Amy's apple is 0.625 standard deviations above the mean, and her orange is 1.2 standard deviations above the mean. So how big would Amy's apple have to be if it was equal in relative size? And so I plug in that z-score and solve for x. Okay? So you need to use z-scores to calculate percentage below or above, and that's also used a lot with probability. Please don't be afraid to use your calculator, especially when you're doing the multiple choice, but please make sure you show your work. All right? So don't just do normal CDF. We need to know what else you're doing. All right? Calculate the z-score, draw your normal curve, remember all that stuff that we did at the beginning of the year. Okay, and this is for the short answer questions. Okay, the other ones, obviously multiple choice, we don't care. Just use your calculator, who cares? All right. Now the next topic we're going to talk about is probability. And to calculate a probability of an outcome, you are going to calculate the number of successes over a number of trials. Okay, really easy. The law of large numbers is huge, and it says as the number of chance experiments increase, the difference between the true value and the relative frequency of success approaches zero. The more trials you do, the closer you get to the theoretical probability. So, for example, this might sound familiar to you guys. You have, you're doing some trials, and the probability of something occurring is 0.5. Well, you've created one where the probability is equal to 0.7, and we're asking you, when are we going, what's the most likely way, what's the most likely number of trials that we'll have to take to get that probability of 0.7? And the thing was, the options were 10, 100, and 1,000. Now what you guys needed to realize is that the more trials I did, the closer to the theoretical probability I was going to get. So I was going to get closer to 50%. So I needed to keep it down at 10. Okay? So when we have, so that's basically the law of large numbers that we use that in actually your multiple choice questions. So what are mutually exclusive outcomes? They're things that cannot occur at the same time. Okay? And that makes a difference when you're doing an or statement. And the probability of them both happening at the same. So I'll talk to you about that a little bit when we get to the or down at the bottom of the page. Independent events are events in which one, if the likelihood of something happening is not affected by the likelihood of something else happening. So the likelihood of flipping a coin and getting a tails and rolling a die and getting a 6, those are independent events because they don't affect the probability of the other one. Okay? Why can two events that are mutually exclusive never be independent? If they're so if they are mutually exclusive, then the other cannot occur. So they cannot be independent. So remember, the U is union and it represents or, and the little upside down, the arc means and. All right, and that usually represents intersection. So when calculating probability of getting more than one outcome for a given event, you want to add those together. Now, when they're mutually exclusive, I don't subtract the intersection of them happening because the intersection of the probability of the intersection of them both happening is 0. Okay? But if they aren't mutually exclusive, you have to take away this A and B. And that, guys, is where the two, you'll see them, I'll draw it on a piece of paper. So this is probability of A, and this is probability of B. And then in here is A and B. Okay? So that's what you're going to want to take out when they're not mutually exclusive. Okay? And if they're drawn like this, guys, big hint, they're not mutually exclusive. Okay? All right. So when you're calculating the probability, so remember to use Venn diagrams, tree diagrams, and two-way tables. Tree diagrams would have been really useful for your multiple choice that we just did. Remember that if they're independent events, you just multiply the two probabilities. When they're dependent, which means the probability of something happening given that the other thing happened, it's probability of A times the probability of B given that A occurred. Remember also that we're going to use combinations when order doesn't matter, and we're using that on our calculator. It's under probability, and I can take you through that. But we can also do a lot of that stuff with our calculator and not having to do this part. Okay, that's with binomial and geometric distribution. Okay, so again, using a tree diagram and a two-way table, understand what each one of these variables mean and how to calculate dependent events. All right, probability that something occurs given another event occurs, that's probability A given B, is the probability of A and B divided by the probability of B. Okay, and then on the back, on the bottom here are a bunch of situations and things that I want you guys to read over. I really hope you guys are looking over this. You should be looking over this every day, okay, from here until the exam. Now, we got to the point where we talked about probability distributions, and that should help you significantly. That was a pretty, this when things started getting really serious. Okay, understand the difference between a discrete and a continuous random variable. Discrete random variables have to have a fixed set of possible values with gaps in between them. Continuous are things like height and weight, where there's a range of values, and if you're trying to find the probability of one given outcome given a continuous random variable, that's always going to be 0. The expected value of a discrete random variable, now this was also a question in your multiple choice. You multiply the outcome times its probability and you add them all up. Okay? And then the expected value definition is the average value over many, many repetitions of the same chance process. Guys, look over our notes and our activities. We did lots of explaining how to explain what this variable means and what this variable means. It's so, so important. So definitely look over that. You guys can do this. I know there's a lot. Khan Academy is helping you guys a lot. I've already noticed an improvement in a lot of your scores and stuff. So, but please also, there's nothing that takes the place of looking over our activities and doing the in-class practice. Okay? Now, to do the standard deviation of a discrete random variable, remember you take the value minus the mean, which is the expected value, which we got up here, and square it, multiply it times the probability, and add them up and take the square root. Okay? And remember that the standard deviation is the square root of that variance. And then when we do transformations, it's so important to understand what transformations do. Remember that adding and subtracting affects the measure of center, but it does not affect measures of spread. Multiplying and dividing by a constant affects the measure of center, and it also affects the measure of spread. Okay? So, and also remember these sums, when you're adding two means together, this is what you do, but when you're adding the standard deviations, be careful. You have to take the variance, add them together, and then take the square root. Okay? Otherwise, you're going to get it wrong. Okay. All right, so binomial and geometric distributions. Remember, we have conditions for binomial and geometric distributions. They have to be binary, which means there needs to be an outcome of success or failure. They have to be independent, knowing that one outcome doesn't tell us what the other outcome is going to happen or have any effect on it. There needs to be a set number of trials for binomial distributions, and each trial needs to have the same probability of success. All right? When you're trying to find one value, when the probability of X is equal to one value, that's when you use PDF, and CDF is when you're doing less than or equal to. So remember, continuous. Now, here are some of these formulas to get the mean. Remember, the mean of X is the number times the probability, the expected value, and then the standard deviation. These are also on your formula sheet. Okay? So, given all this information, you're given these problems right here where you're trying to find the probability of each event. And this is, I'm showing you that how to calculate them. Some of them are geometric, or you can do binomial CDF. For each one of these, I probably would do binomial CDF for each one of these, but then using this, you're going to plug these in, but you first need to calculate your new mean and standard deviation. Okay, so very important when you're doing a binomial distribution or probability that you guys calculate the mean and standard deviation before you calculate this probability, because you have to plug it into normal CDF. Okay, so next one is geometric distribution. And the difference between that is we want to determine how many trials we need to do in order to get one success. The events need to be independent as well. And you can use PDF, geometric PDF or CDF, and you can also use binomial PDF and CDF for the other one, for the one that we just previously did. Okay. So the expected value of the geometric random variable is equal to 1 over p, and the shape of the geometric distribution is always skewed to the right. So go ahead and take a look at some of these. This is all using geometric PDF on your or CDF on your calculator, but you could also do some of these manually, like I did with right here. So geometric CDF here, and then I did this one as well. So okay, so take a look at those and definitely try to work on those with your calculator. Okay. All right, so I'm going to finish this one up. Yeah, that's all I'm going to do. I'm going to do sampling distribution next, but I didn't want to make these too long. Okay, and I think a lot of you guys, we've gone through most of these notes together in class, except for like up till topic 10 or 11, maybe 9. Oops. Anyways, but I'm going to continue to do these videos, and please let me know if there's anything else you want me to go over. Okay, again, I'm happy to help you guys, and I'm here for you, so just let me know what you need.